Hi, welcome to our video lesson about two-way tables. In this lesson, we'll be talking about a way to organize categorical variables. So, suppose we decided to do a survey in our class about pets. Now, there are a lot of questions we could ask about pets. We could ask how many pets people currently have. We could ask how many pets they have had over time. We could ask the name of pets. We could ask who takes care of the pet. But suppose that we just wanted to ask, are you like a dog family or a cat family or both or neither? So if that were the case, there would be 4 different responses a person could make. They have cats and dogs at their house. They have cats at their house but not dogs. They have dogs at their house but not cats. Or they have neither one. Okay, so if all we were interested in were dog and cat ownership, those would be the 4 possibilities. Now those 4 possibilities could be organized into a table, and this would be the way the table could be organized. We could have the variable I own dogs organized against one side. So this is having a dog, doesn't have a dog. And we could have the variable about cats, owning cats, not owning cats, organized in the other direction. So this makes it a two-way table. There are 2 variables organized one against one edge, the other against the other edge. And then you can see the 4 different combinations that we just spoke of, and there would be numbers in each of those cells. So down below I wrote to you, this is an example of a two-way table. The 2 variables in this table are cat ownership and dog ownership. Those are categorical variables as we define them because we didn't ask how many. We didn't ask for a number. We just asked for yes or no. Now, if we had asked for a number, we would organize our data with a scatter plot, because in a scatter plot we can have 2 axes, and the points in the scatter plot would be numbers like something like this, right? 2, 3 or something like that would represent I have owned 2 dogs and 3 cats in my life, or something like this, okay, or vice versa. But we didn't ask about quantities. We just asked about categories. Are you a cat owner? Are you a dog owner? And so because these are categorical variables, the way we define them, scatter plots are not possible, but a two-way table is. So let's say, I actually am just going to make up numbers for this because I can't ask you in this video about cat or dog ownership. So I'm just going to pretend that I asked both of our classes about cat and dog ownership. And so let's say that there are 7 people who have both dogs and cats at their house. There are 3 people who have a cat or more than 1 cat but no dogs. There are 18 people who have at least 1 dog but no cats, and there are 4 people who have neither dogs nor cats at their house. So that would be our information. Now when you do a two-way table, it often helps to have numbers that are like marginal or line or column totals. So if we were to add up how many people would say that they have a cat, we would add along this row and get a total of 10. So this means that there are 10 people who have a cat. That 10 doesn't describe anything about dogs. It just is about the cats. If I were to add up this row, going this direction, I would find out that there are 22 people who do not have a cat. Okay, they might have a dog, they might not have a dog, but 22 in total do not have a cat. And then if I were to add in the vertical direction, I would find out that there are 25 people who have dogs in their household, and there are 7 people who do not have dogs in their household. Now, those green numbers just tell me about dog-type things. The red numbers just tell me about cat-type things. And then out in this corner, if I were to add 10 and 22, or if I were to add 25 and 7, either way, I would get a total of 32. This is what I refer to as the grand total. That is how many people participated in this survey. So, based on what's inside the table and then also what's at the edge or the periphery of the table, we should be able to answer the following. How many people do not have a dog or a cat? That's actually a number that's in one of the cells, right here. There are 4 people who own neither a dog nor a cat. The next question is, how many people have 1 or more dogs? So this question does not reference cats at all. It's just a dog-related question. So I'm going to look at my dog total for this column, and I see that there are 25 people who own dogs. How many people have cats? Well, that question doesn't mention dogs at all, so I'm just going to read across in my cat direction here, and I see that there are 10 people who have a cat in their household. And then how many people have at least one pet? And by pet here, we really mean dogs and cats rather than lizards or fish or anything else. But how many people have at least one of these kinds of fuzzy animals? Well, that would be the 7 and the 3 and the 18, but not these guys. Okay, so I could add 7 and 3 and 18, or I could say, well, there's 32 in all, and there are 4 people who didn't have either one, okay, from that one box with the purple around it. And so that leaves us with 28 people who have at least one pet. Now, the point of doing a two-way table is to be able to actually answer probability questions. So there are 3 different kinds of probability questions that become really clear when you have a two-way table of your information. The next 3 pieces of information in this lesson all have a vocabulary word and an idea of like how you compute something. So pay attention to both the vocabulary word and the idea. Okay, so the first kind of probability I could ask you based on a two-way table is to ask you something called a joint probability question. Joint probabilities, so there's your vocab, is where you want the probability of being in one particular row and also in one particular column. So an example of that for our data is we might want to know the probability of a person in our group having a dog and not having a cat. Okay, so joint probabilities are going to include this word and the way that you find them in a table is by taking one of the cells. Now a cell is just one of those little boxes, and you're going to divide by the grand total. So if we wanted to find the probability of having a dog and not a cat, we know we're going to end up, because of this word and, we're going to end up taking a box and dividing by the grand total. Well, I remember our grand total was 32. Let's look back at the table. Who were the people who had a dog but no cat? Let's see. Dog, not a cat, was this part right here, the 18. So that's going to be my probability. Okay, 18 out of 32. I found that with taking one of the cells, one of the boxes, and dividing by the grand total. The second kind of probability is called a conditional probability. And the word condition, you might remember from when we were doing our probability unit, is like the word if or given. So I might say to one of my children, you can go out on Friday if you clean the garage first. So cleaning the garage first would be the condition under which going out on Friday could happen. So, for example, in this chart that we're looking at, and in terms of probability, we might want to know the probability of owning a cat given that the person is a dog owner. So, probability of owning a cat given that you already are in the group of dog owners. So in conditional probabilities in two-way tables, you again are going to have a cell count. One of the little boxes is going to be on the top, but this time you're going to be dividing not by the grand total, but by a row or column total. So let's think about why that would be. Go back to our table. This was saying the condition was given that you're a dog owner. So I'm not interested in everyone. I'm only interested in this group. These are the people who are dog owners. And how many of them are there in total? 25. So what is the probability of owning a cat if you're one of those 25 people? 7 out of 25. 7 people own cats out of 25 dog owners. So, that down, 7 out of 25. Okay, now that was a conditional probability, and it's different from the joint probability, because joint probability you divide by the grand total, and the word here is and, the key word in identifying it. Whereas in a conditional probability, you're going to have the word if or the word given, and you're going to end up dividing not by the grand total, but by one of the row or column totals. Okay, the last kind of probability that can be asked based on two-way tables is what is called a marginal. Whoops, sorry about that. Is what is called, had the wrong tool, is what is called a marginal probability. And in a marginal probability, you use only numbers that are in the margins. The bottom number is going to be your grand total. I'll write this up here. The bottom number is going to be the grand total. And then this is either going to be a row or a column total up at the top. And you can identify a marginal probability because it only asks about one of the variables. So for example, the one I wrote up here is, let's say we want to find the probability that someone in our data set owns a cat. Now, does this question mention dogs at all? No. So I know it's a marginal probability question because it's only asking about one of my variables. The grand total that we had in our problem was 32. And I'm interested in how many people had cats. So I'm going to read and find out how many people had cats. And that was 10. So I would say 10 out of 32. Notice where the 10 and the 32 were in my chart. 10 was on the edge, 32 was on the edge. That's why we call it a marginal probability. It only uses numbers in the margin. Okay, so here is another example of a two-way table, and I purposely didn't put numbers in there because I wanted you to focus on the structure of this. Let's think about what the two variables are. What variable is this? Hopefully you thought gender. And what variable is this? Grades. Okay, so in each of these boxes I have just a little symbol, and that would that is supposed to represent what's in one of the cells. So in this cell, for example, this is row 1, column 1. That's why I wrote R and C. And that cell would represent males who get A's. Okay? And then as you read left to right, out here at the edge, we have these row totals. So if you look at this number here, that would be the number of people of either gender, or both genders together, that get D's. And then we also have column totals here and here. This would be the total number of guys. This is the total number of girls. And down here we have our grand total. So this two-way table actually has the marginals included at the edges as part of the chart. Okay? So let's think about each one of these. If I were to take R2C2, let's see, that's right here, and divide it by the grand total, what am I finding the probability of? Well, since I'm taking a cell divided by a grand total, I know this must be a joint probability, which means it's an and kind of question. So I must be finding the probability of being female and getting a B. So probability female and BF. Okay, the next one says what is C2 divided by the grand total? C2 is the total number of females, and there's no mention in the question about grades. So this must be what we would call a marginal probability, and it is just the probability of being female. Next one says, what do you get if you take R2C2, so the cell again, and divide by this? Well, if I'm taking a cell and dividing by a row or column total, that is what we call a conditional probability. And since the row that I would be in would represent B students, this must be the probability of being female, given that we're looking only within the group of B's. So if I took all the B students and put them in a room, this would be giving me the percent or the fraction of people in that room who are female, okay, ignoring all the other characteristics. And then the last one here is also going to be a marginal. I can tell because I have a row total divided by the grand total, and row 2 are the people who have B's. So this must be just the probability of being a B student. Okay, so with that in mind, now problems with numbers should be even easier, okay, because I've had a lot of letters. So, on the practice problems, 40 children are members of a cycling club. Details of their bikes are given below. Each child has one bike. Now there are some numbers that are missing here, so this is going to be a little bit of a puzzle. I would say let's total up what we can. So mountain bikes, if we add those up, we get 11. And if I total the rows, this row is 2, the next row I don't know, this row is 9, this row is 15, the last column is 15, and we got to figure out what goes in there. Okay, now it's set up here that there are 40 children, and each child has only one bike. So if this is 40, then we can kind of work backwards, and this would have to be 14 in order to add up to 40, which means that this would have to be 6, which means this would be 14. Now let's just double check. 11 plus 14 plus 15, yeah, that's 40. Okay, so we have the number right, and down here it asked us some questions. So fill in the empty cell, we did that. That was 6, and we found the row and column totals and the grand total. How many children have mountain bikes? What would you say? Hopefully you would say 11. Given that a child has a racing bike, so assuming you're looking only within racing bikes, what is the probability that it is also a 12-speed? So if we look within the world of racing bikes, that total is 14. And then 12 speeds are 6. So this would be, oh wait, hold on, did I do this right? Hold on, I think I did it backwards. This is okay, no wait. Given that a child has a racing bike, what is the probability that it is a 12-speed? Oh, that's right. So 6 out of 14. Okay, sounds good. Somehow that seems a little weird to me, but I'm going to just go on, I think. Racing bike, 12-speed. Good, all right. The next line. What is the probability that a randomly selected child, oh, I think I know what's wrong. Okay, so the next question says, what is the probability that a randomly selected child in this group has a BMX bike? So we would go back here and take a look, and BMX bikes total 15, and so that would be 15 out of the 40 kids. The next one, what is the probability that a randomly selected child in this group has a 12-speed bike? Well, we got to look and see how many 12-speed bikes there are. And there are 14. So that would be 14 out of 40. The next one, what is the probability that a randomly selected child in this group has a bike that is 15 and a mountain bike? So that's one of those joint probabilities. So I want to look for 15 speed and a mountain bike. That's just this cell right here. Oh, my pen isn't working. That's just this cell right here. So that would be 2 out of 40. Okay? At the end of your notes, there are a couple of questions, and you're going to need to draw your own two-way tables for these. I would suggest that you start the next one with hatchback being here and non-hatchback. So a car either is or is not a hatchback. And blue versus okay, and then the other question is going to ask you to look at boys and girls. So let's try that. Boys, oops, girls, and playing hockey versus not playing hockey. At the start of our next class, we will check and make sure that you actually did these problems. So use some space, in your paper, find some paper where you can have space and draw these. And the questions that I want you to answer are right down here. Okay, so make sure you have those done. That's going to be our homework check. Thanks so much. Bye.